ακούσουμε. Πολύ ωραία. Yes, F5 for screen. Great. So, hello, my name is Maria Paschalidi. I'm a student at the university, the Department of Aerospace Science and Technology at the National and Kapodistron University of Athens, here in Greece. And today I'm gonna talk to you about Cubesats. I'm gonna make a brief introduction to nanosatellites. So, who are we? Here you can see some photos of me and my team. Our team at the university has a lot of projects running right now. One of them is our robot, Athena. Here you can see a Cubesat. And our field of interest is STEM, aerospace, satellite mission, space instrumentation, radar systems, and many other interesting specs. So now, about Cubesats. Cubesats is like pretty small satellites, about 1 kilogram, and they typically are 10 centimeters each side. So you can see the similarity with a Rubik's Cube. And we can find them at their own or at a system of Cubesats. Here we can see the Cubesats units. We start for the 1U, that is the fundamental unit, and we go down to the 12U. All of those are in the spec of this one is a 1U, and this is the 3U. You can see it's actually pretty easy to understand. And now all of those are in the spec of the nanosatellites. So we are going to talk about those today. Next thing, why Cubesats are so popular? They are really fast to make. We can build them within 2 years or less. Secondly, they are pretty economical because the materials that we make them are expensive. The materials is very cheap, so we can lower the cost of the whole mission. The technological, they are technological simple. We can make them with pretty easy components, and also they're also easy to design. And something that in our days is very important is that we don't have space debris. So they are eco-friendly. Here we can see some components. They are out at the market. Actually, you can buy them in eBay, Amazon, all of those, and make your own. The only hard part of this is the lamps. But there are few companies that help you with that. So, what the Cubesat can do? We can see 4 aspects there: technology, science, education, and the commercial applications. I have some examples. I don't want to lose time in the description. We can see that they, for technological, for example, we can perform a study for a thermal camera and the evaluation of its performance. Secondly, we can collect information about Earth's magnetic field to better understand in order to predict earthquakes, for example. Then we have, for educational purposes, we can study the global climate change with the help of satellite data. And at last but not least, provision of high resolution photos from Cubesats to customers in the field of agriculture, urban planning, and more others. So we can see that they are not as far as we think the Cubesats. Now, what Cubesats have in common? Those are 3 aspects. Oh, sorry, there has to be a 3. First of all, antenna system and intercommunications. All Cubesats and satellites, of course, have those for us to connect and send and receive data in other information, critical information. Secondly, the power source. The power source is the solar panels outside of the CubeSat, but also and the battery that have for the energy supplier, and secondly the computer, like the brain of our CubeSat. So those are three really common systems. So here the system overview. We have the command and data handling, the telecommunications, the power system that we talk right now, satellite, payload, mechanical structure, altitude determination, and control. These are the main levels of a CubeSat. Now, about the structure of a CubeSat. We see here some aluminum structures. That's the more common material right now out there. And it helps us to be very strong and to not, out there, they're very extremely environment, so we can protect our satellite with aluminum and also put there all the additional mechanisms. Also now a very trending way to make satellites is the 3D printing. Here you can see a GIF from ESA that right now tries to print the structure of the CubeSat. After I said you that out there is a very extreme environment, so the correct choice of material is particularly important. So we should take into account the density, thermal expansion, radiation resistance, modulus of elasticity, strength of our materials that we send. The next, here is a very interesting for me example. About a few years ago, NASA sent those small materials to see how they interact with the external environment of out there. So if you see how they change, that's the before and that's the after. So we see how dangerous for our CubeSat the environment is. I think that's actually interesting. And now, something really important for our whole mission is how we prepare for it. At those images is the GMAT software. We are trying to prevent bad things will happen to our CubeSat. So so we know before we send it exactly where and when the CubeSat will go. That's for our safety and of course for the satellite safety. Here I spoke about a little bit for launch. The launch is the most important and more dangerous part of the whole mission. There are two ways. The first way is that we launch into space through a rocket. They are packed in a box. At the push of the button, the CubeSat can be placed out of the space. Here we see the Starlink satellite mission from SpaceX 2 years ago. Just a moment. You will see we don't send one satellite. We send approximately 50 or 60 satellites at one launch. That's amazing. That's how the cost is reduced through the times, and that's our part. Right. The second way is to put it out there through the ISS. There is a unit called Japanese Paschalidi. and from there we can launch the satellites without a rocket. So when we send it, we should sometimes make his orbit again because of some maybe space debris has hit our satellite and our first orbit isn't the same anymore. So we put sometimes thrusters, magnetorquers, or other mechanisms. Here you can see how the thruster can help us to go back in our orbit. Now, that's really important, the data from satellites and from Cubesats. Here we can see some pictures from the Earth. Sometimes we can take data for the universe, but it's mostly the more common Cubesats are focused on Earth. So we can put thermal cameras, we can put radio cameras, and have a full spectrum of the thing that we focused each time. Now, the enemies of Cubesats. Space waste is an issue that started in the last 1950s and becomes a major issue in the last years. Over the years, thousands of satellites and space objects have been put in orbit. Mainly, the problem lies are inappropriate and roam aimlessly to this day. The problem lies in the collision of these objects with new satellites or with the International Space Station, which cause irreversible and serious damage to either their bodies or their operating system. Space debris travels at breakneck speeds and it's very difficult to reach. So it's really critical to have other mechanisms to fix our satellite before that happens. And when our mission is complete, what we do then? Last 10 years, before 10 years ago, the big satellites were not come back to Earth, but we sent them in another orbit far away from us. Now, with CubeSats, we can prevent to leave space debris and return them back to Earth, so they get inflated and we don't leave any of their materials or harmful and hazardous mechanisms they have. And that's an interesting fact about CubeSats. In 1999, it was the first CubeSats made from a professor from California University and Stanford University, and he made it actually for the students because it's a really difficult field to approach. He invented nanosatellites and CubeSats to make the education easier for the kids.
What is the number of this real text and we don't
yes,
see what
sorry, 510. 510.
500?
Yes, 510. Yes, CubeSats. Now, I think it's outdated. Now it's more than 1,000 actually. Yes, with the Starlink and the SpaceX.
Starlink even more.
Yes, every day. That's actually interesting. All right. References, and thank you for your time.
Questions?
Do you have any? Great. Thank you.
Okay, very good. The next paper for this session is by Professor Ludmila Linik from Estonia.
Yes, from Estonia. Αυτό θέλει να το κλείσουμε. Δεν πειράζει.
And I took some pictures and I'll send to you.
Thank you.
And you need your